Hello and welcome back to Masculine Learning and Maski TV. South Africa and across the world, we are here yet again to try and assist our young, beautiful mathematicians coming forward. Today we are with grade 9 and we want them to learn about the geometry of a straight line. So let's hit into it. Okay, so the learning objectives of today's session is we will learn more about the relationship that is formed between the lines that we call perpendicular, the lines that we call intersection line, which literally shows vertical opposite angles. So you can see that there at the bottom we've actually indicated the line that is perpendicular is the first one there, and as well as the one that is intersection, it's the second one there. So you can see that when we say perpendicular, for example, we always have to remember that perpendicular lines form a particular special angle that is 90 degrees, and we have indicated it like that. If it's never indicated with that small square, then those lines are not perpendicular to one another, right? When we have the intersecting line, we have angles that we indicate that opposite angles are equal, and these opposite angles we literally call them vertical opposite angles. Then we have parallel lines that has a line that we call transversal line that cuts between the two lines, or many that are parallel. So you can see the line that we are having here. I'm just going to try and label it A, B like that. That will be our transversal line that is cutting the two parallel lines. How do we know that the lines are parallel? We need to have this small arrow that is showing the same, and that it shows that it's parallel. So if it's one, that shows that those two are parallel. If it was two of them, also going to show that the other two lines are parallel. So please bear in mind with that as we go on. More example and the definition of perpendicular lines. As I said, perpendicular lines is the two lines that you can have, and wherever they meet, they make a 90-degree angle. So I've shown you an example with these two lines there, as well as when you have a right angle, the triangle that shows a 90 degrees, just like that. Our example in real life is when we have a T-junction. In this case, our T-junction is also showing that we have a perpendicular angle somewhere there, if you look at it properly there. So this is one of the examples that we can use in real life, what shows that we have perpendicular lines. Okay, so with this one now we have something that we call parallel lines, and with parallel lines, therefore, we have two lines as it's shown like this, and it does have to show that it has this arrow there. You can see the arrow, and do not forget the transversal line, which is this line that shows there, because for parallel lines, if we do have this transversal line, then we can do the relationship of the angles. And you can see the example that we have there, which is showing some of the angles. And you see as when we describe it more further that what is the meaning of that. But the very important one is, as I said, you can see that in line LN, there's one arrow there, but then in line KM as well, there is one arrow. That symbol means that line LM is parallel to line KM, right? So let's show it this way. Okay, so line LN is parallel to line KM. If you look at that, you'll be able to see, because they all have one arrow that is showing that they are parallel, all of them like that. So same applies to the other ones that has two. If you check the line KL, so the KL is this line here. It does have two arrows, as well as MN have two arrows. That means that those two lines are then parallel. KL is parallel to MN. By the way, when we write a parallel lines symbol, we just use the lines that I am trying to show here. If you look at it, you will see that I have been using this two equal signs that are standing like that. So this is the sign of showing parallel, right? There is a sign that we use to show perpendicular as well. So that is the sign that looks like a perpendicular shape, just like this. So if you see something like this, that means perpendicular. So that will be meaning, for example, we would have AB is perpendicular to DC or CD, if that is what is drawn for us to check, right? So always when you see this kind of symbols, as I've indicated, remember that this is a perpendicular symbol and this is a parallel symbol, right? Okay, and an example of real life parallel lines, there's a lot of them. In parallel lines, we can use a road and we can use a rail lines where the train are moving. It's also parallel, because what happened is if these lines were not done using a parallel ideology, what will happen then, it means that the cars will always bump each other. So they use parallel space or parallel ideas for them to put the lines like they look like in the road like this. Okay, so let's just do a quick recap on about parallel lines as well. So in each and every parallel line that is given to us, so you can remember from our grade 7, our grade 8, that with parallel lines had 3 special angles that we have to know, remember, and find a way to memorize them. So those special angles are one we call corresponding angles. For as long as there's a parallel line, the corresponding angles will always be equal, right? So if you check on our first here, you can see that we have a parallel line which is showing one arrow like that. So we are sure that we're having parallel lines. So if I try to trace my parallel lines for me to come up with a shape that is F, then I can be able to see what is what. So I can go from this side and I go to where the angle X is, then I go down like that, and then when I go draw it this way, you can see that my underarms of my F there is actually having the angles X and Y. Symbol means that X is equals to Y. So as long as you have parallel lines and you can trace those parallel lines through the transversal line and you have your F, and then you are able to find your underarms angles, that gives us that is equal. So we're going to say that now the corresponding angles are equal. So always remember that, because it's one of the important one. If they were not given to be parallel, you cannot say that they are corresponding angles that are equal. Yes, you can say they are corresponding, but you won't put the word equal, right? So equal, it is said because we have our parallel lines. All right. Now, when you go to alternative angles, so alternate angles, just when you try and draw, you find your Z. So see what I'm doing there. I am finding the Z. Where must it start? From my one parallel line to another through our transversal line there. So that is what we have. And angle X will then be equal to the angle M, because we can see our Z. Remember, the Z can be in any direction. It can look like N, it can be on the looking at the left side or other way around. As long as you are getting the Z there, that is what is important. So it doesn't have to be the Z that is going from one side. It can go from this way, and then I stand here and I go that side. That is still a Z, so which will mean that an angle that I find there will literally be equal to the angle that I find on the other side of the Z. So please remember that the Z does not really have to be always the one that you see in your alphabet, but it just have to have the shape of a Z or an N or a Z that is looking upside down. All right. Then we have co-interior angles. So co-interior angles, they are not equal, but the sum of the co-interior angles add up to 180 degrees, which we usually call it supplementary in the language of maths. So they are supplementary, and that is a U shape. So you can have your U shape looking up, you can have it looking down or sideways. Anyhow, that is what it determines the co-interior angle. As well, you need the parallel lines and which is corresponding or using the transversal line like that. So if you add X and Y, you must get 180 degrees, and that is what. Here you can see that the summary that we're busy talking about, it has been nicely highlighted and summarized here. So co-interior angles, as I said, they add up to 180 degrees, and our purple shape there, it's actually the one that shows co-interior angle in that way. While we have corresponding angles are the angles that are equal, and also they are the underarms of our F kind of a shape. So that is the first one there. And then we have one which is alternate angles, which are also equal, provided we are given the two parallel lines, and also we know that the transversal line is cooperated there. Okay. Now, the last type of angles that we have, as I said, they are the angles that we can see that in this diagram. For example, on the left, we have a line P. On the left, we have line PQ. So you can see PQ is this line there. And then we have line RS, but in between you can see that there is T. So that T is actually the center, or where the two lines are intersecting, right? So this always show the angles that are vertical opposite angle. And in summary, we write the vertical opposite angle as vert op angles, right? So that is how we write it in summary. But here we can actually say P angle TS, which is this angle there, equals to R angle TQ. So we can say that. So remember, there's different types of writing angles. We can say P angle TS and we put the head, or we can put it on the side and we say PTS. We are still saying the same thing in this context. So we are saying these two angles are going to be equal, or they are equal. So R angle TQ, they are equal, and then reason will then be vertical opposite angles. Always when you write the angles in geometry from now on up until wherever you're going with it, you always have to write the reason. Why are you saying that this angle is equal to that angle? Why are you saying that this side is equal to that side? So you always have to put down the reason of me saying that P angle TS equals R angle TQ is because I have vertical opposite angles, right? Angles that are equal. So that is what I am going to write as my reasoning to say that those two are equal. Let us do a little just activity for us to see through this with this vertical opposite angle. Suppose the question come and say to us, let's find the value of X right on that other side. So for us to find the value of X, we're going to say angle X is actually 125 degrees, and Y, so we're just going to tell them that is vertical opposite angles, just like that, because we know that vertical opposite angles are equal. This only applies if you have a straight lines or two straight lines that intersect. So it's not for any other shape that is not a straight line, and you cannot just assume that each and every shape is a straight line. You have to measure it, you have to be told that that is a straight line, and so on, right? Okay. More examples for us to do here. We have a parallel line example. You can see in here we're told to determine the value of the variables that is there, that is given. So let's quickly just redraw it for us to remember. So I am just going to redraw it the best way I can, since I do not have a ruler. But you guys will forgive because you can see the sketch is there, but I'll try my best to draw it properly there. Let's see if it came out right. So we do have labels as AB and also CD, and then the transversal line is not labeled. How do I know that this is a transversal line? It is because it's not shown to be a parallel line. How do I know that? Because the lines or the arrows are not drawn onto that line. So that become our transversal line, which means that our parallel lines is AB and CD. Okay, so I was told, or I was asked to find the answers here for A and B. So let's see how we're going to find A and B in a very quick and simple way, right? So to find A and B, we would need to first trace our shapes. Remember, we have the shapes that we spoke about. We have our vertical opposite angles, we have our parallel lines, we have our perpendicular lines. So you first ask yourself, do I have perpendicular lines? No. Do I have parallel lines? Yes. What do I do with parallel lines? Try to see if I can see an F shape. Try to see if I can see a U shape. Try to see if I can see a Z face. So that's what you do. So since our lines that we are talking about them being parallel is A, B, and C, D, if I start here, you can see what I'm trying to do. If I start here and I go down like that through my transversal line, I do find that there's an angle somewhere here which can give me an F. Can you see that angle A will then be equal to something there? But that is when I use my space there. Okay, so if I use, where's my angle A? My angle A is on the other side, so let's write it where it's supposed to be. That is where my angle A is, sitting that way. So if I write it this way, do I have anything? No. Although I know that the angle that I'll find there will be equal to the angle that I'll find there, it will take me quite long for us to get to the answer. We might, but it will take us long. So let's try another direction, which when I draw it this way and I go down and I go this way, can you see my F? It's now my F is happening and I do have my underarms like that. So that means I can come and then put some conclusion and say, voila, A will then be equals to 65 degrees. Why? Because I have corresponding angles. So that is corresponding angles that are equal, right? Corresponding angles are equal, but you don't just say corresponding angles are equal. You literally have to specify which lines are given to be parallel for that to happen. So you're going to come and say, because AB is parallel to CD. We can summarize the word corresponding by just writing C-O-R-R and just put a dot like that, or C-O-R-R-E-S-P, but then we know that its corresponding angles are equal, right? So we have found one, which is A. Immediately when we find A, if you look at it, we can now be able to find the B there. Let's quickly find it. Okay. We have lost our line, so let's put it back. There we go. So we can be able to quickly find B, but how will we find B? We would have to use another information that we have. So if you look at where angle B is and angle A, you can quickly see that you have a vertical opposite angles. So what you're going to say, you're going to say that A is equals to B plus 20 degrees, right? When you say that, that is where you come and say, this is because I have vertical opposite angles that I know that they are equal. So you're going to write it like that, and then you're going to then solve for B. Now we know that angle A has been calculated, or we have proven that is 65 degrees. So we're going to substitute that, and then we have B plus 20 degrees. Then we go subtract the 20 both sides, right? If I subtract 20 both sides, I'll have to subtract 20 here as well. Okay, let's do that. Minus 20. Remember, it's 20 degrees. That will be equals to B plus 20 like that. But our 20s will then cancel on our right, because 20 minus 20 will give us 0. That means that B will then be equals to 65 minus 20, which will give us 45 degrees. So in this way, we are able to find the solution, and you were able to say that angle A is 65 and angle B is 45. Okay. Now let's see if we can do quick works together. But as you are seeing that, or you are checking that, I am going to just give you a few minutes to settle down. This was taken out of our platinum textbook. And the platinum textbook that we have, that was actually on page 92, that you can have many questions from it. So please, if you have your book with you, let us start opening the platinum textbook. If not, you are able to buy it online instantly and you get it as a PDF, which you can use. But if not, still, let's work together to get to the solution of what we are looking for. See you after the break. Okay, let's see if we managed to do that. But before that, we had one question from Lindile, and the question was, why are we saying that co-interior angles are adding to 180 degrees? So the reason for that is due to the nature of the lines that we are working with. So you can see that this is a straight line that we are talking about. So remember that the sum of the angles in a particular straight line is always adding out to 180 degrees. So that is the concept that we are taking there to come and say, whenever you have a straight line that you have there, would have to give you the values that's supposed to add to 180 degrees. So you can see that if we had another value here, that will be our 180 degrees minus x, as well as the one that we have there will be 180 degrees minus z. So with that context, that is why we end up saying that the addition of the two are going to be co-interior angles. I hope I've managed to respond to Lindile's query, and if not, we are always here to reply to any questions. Okay, so let's see if we can manage to do this one together and quick. Okay, so the question says, calculate the unknown angles in each of the following, give a reason. So we need to give the reason to the statement. As we are doing that, I hope you guys have already answered these questions, because they are easy, right? Yes, they are. After all this, we have managed to understand what's going on. So please, let's put the answers on the chart, as I am also doing it for those who did not get it right at the moment. So number A, we are asked to find the value of x. So as I said to you, for you to get this right, you just have to trace, right? So if I trace from this side, as I always start, because I'm looking at my parallel side and I say, oh, this is jackpot. But you can see my jackpot is not winning me, because I'm actually going to the other side. I do see that I do have my underarms, which will be equal, but it's not where I have to focus on. So I will change my style, and then I go do it on the other side. So let's see if I draw my F there. Voila, that is where my x will then be equals to 80. So that is how you're going to respond. You're just going to say x equals 80 degrees, and then you give the reason there to say that these are corresponding angles, right? So corresponding angles are equal. Remember to always put the lines that are parallel. You don't just say that and you run. So EF is parallel to CD. So that is how you get to that questions or to that solutions, right? Number B, we're going to do the similar thing. So now you guys can run. You can be able to tell me the answer without even me saying anything. So if I trace from there, I go to my transversal, go down to my parallel and back to the parallel. Can you see the Z there? I can see the Z. So that means that our X for that one, it's going to be equal to 35 degrees. And then you always write your reason. Why are we saying that? Because we have alternating angles that are equal. And that is because we have parallel lines DE and which is parallel to what? FG, right? So that is how you respond to that one. This is very, very easy, and I'm sure all of you have managed to say what it is that has to be there. Now we have one more which says we have two parallel lines, but if you trace it, you can see that we have a U instead, which we are saying that the two of them will therefore be co-interior angles. So we're going to come and say X plus 40 equals 180 degrees, and then we say that that is co-interior angles are supplementary. So we don't say they are equal, but we say they are supplementary just like that. All right. Then we solve for X. Remember how we solve for X? We remove whatever that it is next to the X, because the X does not like many people, right? So we have to try and remove our X there right away. For us to remove the X, we need to subtract, because this was, for us to remain with the X, we need to subtract 40, so that we can have 40 minus 40 to give us 0. But what we do on the left, we must also do on the right side, and that gives us the value of X to be equals to 140 degrees, like that. So we have looked at all of them. You can see we have summarized corresponding angle, alternating angles, and co-interior angles whenever we are given our parallel lines. Remember that is where you can use it like that, the way we did. There's many other questions that I would like us to do, but as I like us to do these questions, I just want to just bring your attention a little bit to the fact that there is questions that they merge them together, which is a parallel line as well as perpendicular line, or they give you a diagram that has all of those, and you can sometimes get more than one parallel lines that are all parallel. So you can see we have this line FB here. It's given to be parallel to line AC as well as line ED. So these are all parallel, right? So what you need to do is just focus on which line is parallel. So in the context for a very quick one, we're going to do number one, A1 and A2. And the rest, I'm going to leave it for you to have something to work on, right? So look at A. What they're saying is that we need to respond or answer what is A1. That is the angle we are looking for. If I look at my parallel line AC, and then I draw to it, I go to A, and then I go down like that to my other parallel line ED, then I can see that actually A1, it's equals to 20 degrees. So that's what you're going to write. So A1, which is for number A, will be equal to, remember that is an angle, so to have our head there, that is going to be equal to 20 degrees. And then our reason will be, we have alternating angles since we have Z. Z is not a reason, it's a shape to help us remember that we have alternating angles that are equal and indicate that AC is parallel to ED. So that is how you respond to that. So I want to quickly just do number B and leave you guys to work with the rest. So for me to find A2, what must I do? You guys remember? What is the meaning of this sign that I have here? If you can remember that, then you are gone. What is the meaning of the sign that I have there within A2 and A1? So you can see that A1 plus A2 is actually given to be 90 degrees. For that is given, so I don't really have to write many things. I can just say this was given as my reason. I've already calculated A1 to be 20 degrees and I am looking for A2. So can you see that algebra is everywhere? Because that is what I am literally doing now to introduce algebra. So I'll remove the 20, but remember, for me to remove that 20, I need to subtract it both sides. So let's quickly do that to subtract the 20 both sides for us to get to the solution. So that's minus 20 degrees. What I do on the left, I always must do on the right side. So that means I'm going to have my A2, which will be equals to 70 degrees. With practice, this become your second nature. You can be able to do it right by yourself. And if you did not understand this particular one, you can always go back to our videos and our lives, and you rewatch for you to get more questions has been set for you with the Platinum book as I've instructed. If you are able to buy the book online now, if you don't have it, as I've said, this is the cover you're looking for. So if you go online, this is the one you have. You can just get into it, or any bookstore you can get that, but most of the schools I know they use it, hence I have been using it to show you guys. And I hope that you guys have enjoyed the lesson and you can now relate to your parallel lines, vertical opposite angles. You can relate to all the angles that comes with the parallel lines in combination with the perpendicular lines as well. I hope you guys have a wonderful, wonderful evening and continue to learn as you are the master of your own life. See you next week. Bye.
And now we enter our next exciting chapter with the launch of Maskiverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.